Analyzing outliers is a process that looks for data exceptions beyond what was expected. Exceptions can be the result of fraud, machine failure, shrinkage, web intrusion, and many other events. Outliers result from a statistical process that identifies values that significantly exceed or fall short of the average value found in a file or a series of similar files. Outliers can be found when analyzing a single data field or by analyzing points on a graph that result from plotting values from the two related fields. Both types of outliers may provide evidence of problems, or perhaps of the existence of a positive business trend you wish to understand and develop. We can look at a couple of examples that can use outlier analysis to determine if unexpected results warrant further analyses. Fraud detection is constantly improving and maturing, as are the skills of those committing the fraud. The financial community has fraud detection algorithms in place today that resulted from vigorous statistical analysis of known fraudulent practices. However, the informed criminal is certainly aware of these algorithms and will attempt to cleverly bypass detection with new fraudulent techniques. Outlier discovery may be the first indicator that new techniques are surfacing in your environment. Transaction volume, transaction time of day, transaction volume plotted against the time of day are all data elements that can have outliers worthy of investigation. Shrinkage can occur anywhere along the supply chain or anywhere along the production line. Products can disappear off the back of the factory floor, off the loading dock, during the transport to a warehouse or retailer, or through the retail operations. POS systems are devised to uncover shrinkage once inventory is sold. But shrinkage along the entire route can be analyzed and managed with a new level of scrutiny using Big Data Revealed's outlier capabilities. Web intrusions come in many flavors. Some attempt to copy data transmissions for the purpose of stripping meaningful information from the transaction for later use. Other intrusions attempt to redirect the browser session to another page, hoping to acquire information from the individual that can be used maliciously. Both of these processes create a high volume of transactions to a specific site, which can be analyzed with Big Data Revealed's outlier capabilities. We invite you to reach out to us and discuss use cases for analysis with Big Data Revealed's outlier capabilities. We believe it will be well worth your while.
What we're going to do is start out with where CCPA and GDPR really begins, and it's where companies do need to begin and where it's recommended to begin, and that is the identification excuse me, of your exposed PII or personally identifiable information. Now what we have built in are two sets of processes. We can use JDBC and go against Oracle, SQL Server, DB2, Teradata, MySQL, Postgres, shortly MongoDB, other non-SQL databases, Teradata if I didn't mention it. So we have a whole slew of databases that we go against, and we did start out going against Hadoop's HDFS, which exponentially is quicker than most. And there are different methodologies people might want to use, because there's more talk about companies going against structured data only or production data, but there are PDF files, there are Office docs, there are OCR docs, there are biometrics, facial rec, object recognition type documents. So we have built in a system to where you don't have to rekeying in existing database type information, and if you're going to use TCP/IP over SSH or SSL, we have all those capabilities built in here for you. So here we're going to take an example, and we're going to go into a database that's existing. We're going to test it. We made our connection. We're going to go into test data 2 as an example. Now, instead of just going out and finding and creating some basic metadata, we create extensive comprehensive metadata down to the columns and rows to where we find PII. But we also let you remediate. You can remediate on the fly. You can remediate later with your ETL tools. You can put the remediated data in HDFS and S3 or in your existing database. You have your choice and combinations as you see here. So in this example, I am going to go and I can create a new schema for HDFS in a database, or if I'm running in a small table, I might want to do the encryption and update directly to a database, which is almost unheard of, by being able to find the PII and do the encryption directly. So I'm actually going to show you an example here where we're going against the schema in a database, Steve1, and I'm going to go to emails, and I'm also going to look for a person named Jenkins because they didn't want their last name being used. So I could do a complete erasure or an encryption. There's a big debate out there in CCPA and in GDPR of what allows you to really do an erasure. Do you need something stamped from the court, from FedEx Kingos, from a bank? What type of validation really allows you to do that? Because people can be doing that unethically or unprofessionally. So here I'm going to go through and I'm actually going to go out real time and I'm going to look for emails and I'm going to encrypt and store it directly back into the database as one example. Another example I'll show you is I'll write it to HDFS for the data scientists and they can get access to the encryption keys and the DBAs will have their databases updated directly, or they can get a copy of it with a timestamp and use their ETL team or their ETL capabilities. Now, if we were to look at MySQL and look at the Steve1 database and table, we will see that the email and Jenkins are not encrypted at this time. Now I'm going to refresh until the job is completed, and once the job is completed, we're going to see that they are encrypted. While that's running, I'll take advantage and just run into our metadata to show the importance and the comprehensive metadata that we store. So for jobs that we were running yesterday, today, whatever date timestamp, you have the control to be able to look at what metadata that interests you. So if it's email, if it's IP address, if it's the clients or customers or the citizens that you were doing right of erasure, what information do you have, you can select that information both by the regular expression patterns or the names of the people, and do the pattern discovery SQLs, because there are several types of catalogs, the beliefs, the pattern discoveries, the quick classifications. So now that I select the job, I run the export process, and we're going to get out of the database. This isn't like a Word document. We're actually having a CSV file created from what's stored in MySQL and what's stored in HDFS. And as you can see, you're going to see in a second, this is our job stats that we have created that we're also going to be showing you, that we're processing hundreds of millions to billions of rows in a matter of minutes. Because we're using Spark memory, we're able to run the memory underneath Yarn to take advantage of it. Here we were looking at today, and what I just ran were emails and searching for the name Jenkins. We can tell you what column, what rows they were found in, how many total rows, row numbers, and again, what we were doing. We were writing to HDFS in the database. We were rewriting to the database. This information is critical to the ETL team, change data capture team. This can also be exported into your existing metadata tools and shared with and collaborated with other tools that you're using. So it really becomes really crucial and important in that process. So now if we go back to MySQL and refresh.
Yes. Test data too.
We will see this used to be Lisa Jenkins. If we look at test data 2 in the originating data, we have Lisa Jenkins and unencrypted emails, IP addresses, and phone numbers. But here, after we did our discovery run, we just didn't do a simple discovery and say, hey, we found Jenkins for right of erasure. We found emails. We actually went in there during that same time period, and we're scalable to tens of millions, hundreds of millions, billions of rows to be able to do it on the fly and put it into a new schema and table or an existing one. Now, in reality, the later company. So here, if we were to come in and say, okay, we're going to look at emails. Now, this is all done with AngularJS D3 open source front end. So now we see that we have emails. What do we want to do with them? Well, we know they need to be either sequestered or encrypted. So we are going to go in to this CSV file sitting in HDFS. We just showed you RDBMS. So I am going to run this process. I'm going to delete the history because HDFS doesn't update, it keeps history. We don't want to keep history on unencrypted data. That's deleting our purpose. So if we want to go in and wait for this to run and we want to look at the file content, while it's running, we can see that our emails are unencrypted, as is the data here. Shortly after, as this job is running, we will be able to see that now this data in email is encrypted. Back to your e-commerce screen, and it's business as usual. But what people are missing out there is there are other things. There are object detection. There's facial recognition. There are PDF files. There are Word documents. There are PST files and Outlook files and the hundreds of different file types. And they can't be ignored. Here's an example, and we are using the same thing that Google has been using for years, and we have built in our own algorithms and logic, in some cases, to make it more powerful than what anybody else is using in OpenCV. Here, on the left side, we have a C programming book, and we were actually able to match it to a single picture that has 10 different books, and we matched it to the C book. We have altered and allowed individuals with facial recognition cases now, and people that are in parking lots, people that are standing at the register at Walgreens, and they're being recorded. These recordings have a right to be missed. Now, this is me, but now we have shortened the distance of the face. We utilize both eyes versus one, and we are tightening up facial recognition. So here, we're able to see we got a hit out of a lot of them, and we are using the algorithms of the training images, which have numerous images, to be able to match against pictures. So the higher the number is, the less chance of getting a proper hit. So a 60 isn't a good thing, it's a bad thing, and I only could wish I could look like Elvis, and I don't. So this isn't me, and this isn't going to help the police or Homeland Security, because that's just not who I am. When it comes to running other types of jobs, as we said, and I think I have an example in here of running a pattern job with a PDF file. We can go against Word documents, PDF files, and we utilize Tika. And Tika is able to break down all these semi-structured files and actually break them down into Social Security patterns and state patterns and various types of patterns to find people, to find Social Securities, and other information. This information is all part of CCPA regulations and GDPR regulations. So just going against production data, just going against what you know about is not enough to be compliant. And we go against all the data. I don't care if you've got 30 billion records. You can't randomize and sample that. This isn't data profiling. You have to, by law, go through all the data. And all the data must be accounted for, or you're in violation of CCPA and GDPR. Now, here is the proudest moment that took a real lot of work. And as Dr. Horn said, we had to do data injection. We had to do a lot of buffer working, and we had to do a lot of bits and bytes and hacking in a clean way ourselves to be able to make something like this happen. So by simply changing a MySQL port of 3306 to our proxy port, that packet of database goes into us, and we are able to manipulate things. We are able to convert non-encrypted data to encrypted and vice versa, and get you the results you need. We utilize our comprehensive metadata that, with utilizing our metadata and clicking on the right metadata, which the hackers are going to have a heck of a time figuring out, is going to know exactly where to get the proper encryption key to be able to then go through the process of being able to do the proper e-commerce, WordPress, and website conversions to be able to allow what you're going to see happen. So here we just built a simple, not a website, but a simple Angular screen in our system. Now I am going to show here that we have data in various formats. And we have people like Lisa, that was, I'm sorry?
Customer table.
Customer table. So we have data. So we have Lisa Jenkins, and she has an encrypted email. And if email is part of what Walgreens or Amazon needs, we have a problem. But we know her name is Lisa Jenkins. So if we just came in here and went with last name Jenkins, because we want to get to that email, and then we need to convert that email for validation purposes. So now we're loading, and we were able to go and convert that input data to match that encrypted data that was compliant, and we have her email. And now we can take this unencrypted email as a sample, get rid of her name, which is both unencrypted in both places. But her email is encrypted. But this is her unencrypted email. We have the capability with our proxy to go against an encrypted email with an unencrypted email and still get her phone number, her email, her first and her last name. Matching for all those delimited fields, you can do a user at a time, you can do 1,000 users at a time. So if you do happen to get some movie actor or actress or a president that decides he's mad at some company and asks 500,000 people to hit you with a right of erasure or right of usage of their data, it's automated. You'll be able to get that information and you'll be able to accomplish it and prove it with all the technical metadata. Should we go to executive summary or just drop down? So here you can see a chart of what we found for emails, what we found for Stephen, what we found for Meister. And you can't drill in yet until you run the pattern discovery. So we'll go in and run a pattern discovery. We have what's called an outlier discovery for anti-money laundering, for parts on an oil rig, where maybe if a part exceeds the standard deviation, that means 10 different parts are going to break. You want to get to that part. So we do have some of that old good data profiling, outlier discovery capabilities of the old times built in here, but we're really more about CCPA, GDPR. And once the discovery pattern completes, this little round box will go away, and then we're going to have our permission to be able to go in and to accomplish the user's request for their information to be erased or encrypted. Okay, so that job is done. So if I go into... I'm sorry?
Yeah, associate job with the pattern discovery.
I'm sorry? Oh, yeah. So we attach the latest job to match to the metadata. I now hit the action button. We now can see all our emails. There I am. If you want to drill down to the system source of record to make sure the corresponding and surrounding information, you can. And then at that point, we go to executive summary.
Yeah.
And in the executive summary, we now have our choice to get rid of Stephen, Meister, or the emails. So I'm going to get rid of Meister. I can sequester it, encrypt it, or delete it, or